Welcome to this lecture on microprocessor 8085 instruction set. We are discussing about program techniques, how we can build and execute programs. Let us start. We have learned about instruction. The use of specific instructions written sequentially to perform a task is known as program. For example, if we have to add two hexadecimal numbers, we'll first place them in two registers. Then we'll add two registers because addition or any arithmetic logic operation takes place in accumulator with the help of ALU. One register for the process of addition must be accumulator. So here is a program to add these two numbers. So for the beginning, what we are doing that we are moving the one number in accumulator MVI A to FH. Then we move the other number in B register MVI B 45H, indicating that the two numbers are hexadecimal. H indicates the numbers which are there are hexadecimal. When we say add B, means that the contents of B register will get added to accumulator, and then we apply the restart RST5 for a temporary halt. So this is a simple program, and if you see that on the right hand side, if our RAM address is starting from 2000, then we can have on 2003E the instruction code and then 2F the data. Then on 2002 we'll have OE, the opcode translation for this opcode MVIB machine code, and then we have 45 as the data. Then add B, we have only instruction code 80, and this 80 will generate the controls to have the addition of 45 to the accumulator. And EF temporarily stops the process of for a short time. We'll start with some other problems, and we can begin with a problem of loading three registers with 3 bytes of data and then copying those contents of the registers to some other 3 registers, general purpose registers. So what we do that we move first the bytes into 3 registers. We select accumulator, B register and C register for loading the bytes. You can see MVI A to F H, MVI B A7H, MVI C 7EH. Then we move A to H, B to L and C to E. So what was the task that has been performed? Then we have a temporary halt RST. We'll see the other program. This program is actually transferring the data bytes which are stored in memory at the location 2050 to 2053. That is shown in the remark also. So we write the program to transfer these 4 data bytes into 4 registers A, B, C and D. So we start with LXI H2050 to be used as a pointer because we are moving the data from the memory to the registers. So first we do this, that when we have loaded the HLPR register with the pointer 2050, then what we do, we say move AM, means the memory at that place, the place will be pointed by the HLPR, and the data movement will take place, means in HLPR we have 2050, that means F5 will move to accumulator, and then we give INXH, means the HLPR will be incremented. Then we do move BM, means the memory at the memory will be now the pointer will be HL will be having 2051, then that means it points towards 2051, and there we have stored 78. So the 78 will get transferred to register B. In the same way, the next 2 bytes also get transferred into the registers, and finally we have RST5 for the temporary halt. Let's have another example. Write a program to convert hexadecimal numbers placed in B and C registers to decimal equivalents and place the results in D and E registers respectively. So what we do, we have to use DAA instruction or DA instruction, which converts actually the contents of accumulator to decimal. So let's see this program. We say first we load the bytes, load some data bytes into B and C registers, say the MVI B 2FH, MVI C 45H. So 2F and 45 is the data in register B and C. This actually is to be converted, every byte individually is to be converted to decimal equivalent and then transferred to registers D and E. So what we do to transfer, first we transfer the register B contents to accumulator, because the DA will take place in accumulator. So we move AB, means B will be moved to A, then the accumulator will be adjusted to decimal, and then these contents, whatever now the decimal contents are in the accumulator, they have to be transferred to D register. And then what we do, again this job is over, 1 byte job is over. Now the next byte 45 we move AC, means we have to move C register to accumulator again to change this 45 data byte to decimal equivalent. Then we apply DAA, means it is converted to the decimal, and then we move the accumulator contents to E. So the 2 registers were individually converted to decimal form and then stored in D and E registers respectively. Let us see the next. Write an assembly program to multiply contents of B and C registers. So what we do, this is a program where we are actually doing the repeated addition, and we are again using here the loop instruction, loop technique. So what we are doing first, that we are moving 000 to A register, MVI A 00H, MVI B 0AH, means one number 0A is placed in B, and MVI C 04 and hexadecimal 4 in C register. So we have to multiply 0A with 04. So then we start the loop. What we are doing, add B. That we are taking the other register as a count and one register as a part to be assembled or added. So we are doing repeated additions. Add B means we are adding B to the accumulator. So once it is added, we decrement the other register so that its content has become, because we have added once, it's a repeated addition technique for multiplication. So we say DCRC, one decrement takes place in the C. Then we check on non-zero till C register is not 0. We ask the microprocessor to jump to a label AD, means it will go again to add B, and it will continue that process till it gets 0. And when contents of C are 0, 0, it comes out and RST5 gets executed for the halt. So the other program is write an assembly language program to generate Fibonacci series. So what we are going to do, we are first identifying the problem that what is this Fibonacci series. It's actually that it starts from 0 and the second number is taken as 1. Then every next number is taken as the addition of last two numbers. So for that, what we do, that we start a pointer so that the contents are stored anywhere in the memory. So LXI H2050 is that we are loading the HL pair with a location 2050 address. Then what we are doing, that we are moving actually the first byte, what we call as 00 in B register and 0B in C register, and 0B in C register means it's for count, that to what number of terms we will print the Fibonacci, because it is going to increase infinitely, so we have to stop anywhere. So we are printing it 0B times or 11 times. So then MVID is 01, the next, or we can say the first is 00, then the next is 01. Then what we do, we move B to M, means that 00 will be moved as the first number into the memory. Then the memory address will be changed, means or increased, that's INXH. And after the pointer is moved to the next memory location, we say move D to M, means now 1 will be moved to the next memory location. So first number which will be in the memory will be 00 and the next number will be now 01. Then we continue with this program because it is it is a big program, so it's on the next page. So I have shown for the comparison the assembly language program on the right side, full program. So what we are then, after moving D into the memory, means 01 into the memory, now we have to start the process of generating the series. So we start a loop, and what the loop is doing, that it moves B to A. That what was placed in B is now moved to A. And then what we do, we add D, means 00 was in B and we have added D, that means now the contents are 1. Now we are again changing the series, we are printing the series in decimal, so we are applying the DA instruction here to convert the contents to decimal. Then what we are doing, move D to B, that what was earlier B will be now replaced with the D. and then what will happen that A will be moved, move DA means A will be moved to D. Now what we then do that, what were the accumulator contents after this addition? We increment the memory means HLPA, and then we load the contents of accumulator into memory means move MA. And then again what we are doing, DCRC, again that the counter which was of 0B, it is to be decremented because we have printed one more number we have printed. So then on the basis of that, how many times we have to print those numbers, it will check that whether this B has come to 0 or not. Till then it will go on adding like this, adjusting it into this decimal notation, and then storing it in the next memory location. So by this process we generate the Fibonacci series up to some terms, some 11 or 12 terms. With this we come to the end of this introduction of how to design write the programs in 8085. Thank you very much.